Hey everyone, in this video we are going to build a battery. More specifically, a replacement battery. More specifically, a replacement battery for this. Now, I have a 3-year-old niece who has a Powerwheel, and this is a 12 volt 9.5 amp hour lead acid battery. It probably weighs 5 or 6 pounds, and it sucks. And this is not lead acid. It is this is a bunch of Tesla Model 3 cells that are available on Battery Hookup's website. I bought these a long time ago, impulse buy. I was like, I'm gonna buy 100 of these. Why not? So these are NCR 21700s, and they are 4.8 amp hours a piece, and they are rated for 10 amps of discharge. So we are never going to have to worry about any kind of discharge issues. Alright, so I should probably sit this down so it's easier to work with, but I'm going to try and do it this way. So this is the original battery, obviously, and these are the 2170 cell holders that I have, and you can see the thickness of this is going to easily be the size of a 2170 if I lay these on their side like this. I probably explained that terribly. Whatever. So I went through and figured out on the front side what would fit, and it looks like this size is going to fit fairly well on the cross section of this. So it might be just a smidge taller. It's definitely going to fit in this direction. Alright, so now that you have an idea of the size that this is going to be, what is the voltage and capacity going to be? Now, I could just build a 12 volt battery to replace this heavy 12 volt battery, but I wish my uncle would have built me a really fun like 18 to 24 volt battery for my Powerwheel so I could make my parents actually have to run and chase me, just me. So we're going to build a 7S, right, 5P battery. So what we're going to end up with is a 24 volt battery and a 24 amp hour battery. So 12 volts, 9.5 amp hours, 6-7 pounds. 24 volt, 24 amp hours, and not 6 or 7 pounds. Lithium for the win. If you haven't noticed, I'm kind of just winging this video. I did zero scripting and I'm just going with it. So if you like it, give me a thumbs up, and if you don't give me a thumbs down. So now I have all of my cells charged up and in the correct orientation to build the battery pack. You can use just this pure nickel strip and cut it to length here and make your parallel connection, and then cut it to length across here and make your series connection, but it's kind of annoying. So I bought this, and this is for 2170s specifically, and you can see how when you lay this on here you make your parallel and series connections all in one. So this is way more convenient, and this is what I'm going to be using. I got this from 18650 Shrink and Cell Holders. It's Keith on the DIY Battery Forum or the DIY Battery group on Facebook. Super nice guy. I also bought this K-Weld from him. This is going to be my first time using it, and I have this Turnigy Nanotech 5 amp hour 65 to 130 C discharge. So they've had good luck with this specific battery. You have to be careful because this is basically a controlled short circuit to the spot welds, and you want to make sure that this battery isn't going to get too hot internally and catch on fire. Fires are bad. So these work well. I have everything all set up and ready to go, so let's get to it. Enough rambling. I think for this I'm going to try setting my K-weld to about 55 to 60 joules and see how that works. I did some testing on this nickel strip to nickel strip, and 50 joules worked, but it was like right on the edge of not having good fusion. So I'm going to bump it up a little bit, and hopefully that'll work a little bit better. So let's get to it. So I just finished this first row spot welding, and this is working extremely well. I have it set to 55 joules, and you can feel the wiring get a little bit warm after probably 2 or 3 welds. And right in here where this connection is, you can definitely feel this start to get warm. Not hot by any means, but you feel it's warming up a little bit. So I tried to give 3 to 5 seconds in between each weld, and then after 3 or 4 welds, give it some time to cool off. And I think this is going to work out just fine. So now let's keep going. Okay, so now I have all of the series parallel connections done. So in theory, I should have around 29-ish volts if I measure from my main positive here and my main negative here. So let's do that now. And we have 29.11, so that's all wired in correctly. I'm sure it would have let me know if it was wrong before this. But, alright, so now I'm going to use some of this just pure nickel strip to make my main negative connection and my main positive connection, and then I have to solder on my balance leads. In hindsight, I should have soldered on the balance leads to these nickel strips before I spot welded it. If I do a battery build again, I'll probably do it that way. That way I don't have to apply heat to these cells, which is a big no-no if you can avoid it, but it's already on there, so I'm going to have to deal with it. Alright, so all the spot welding is done. Now we are ready to solder on our balance leads. And I think I'm going to go through and pre-tin this. I'm going to put a blob of solder on all of these connections first, and then go through and solder these into the blob. I think that might make it a little bit easier. So the solder I'm using is rosin core lead solder. This is 60% tin, 40% lead. 0.032 inch diameter, so it's a little bit thinner to make it a little bit easier to handle. This does have lead in it, so don't eat it. Don't lick the residue off your fingers, and don't breathe in the fumes. But the reason I like this is because it's rosin core, so I've never used flux, but the rosin cleans things up pretty well, so it's easy to solder. And also it has a lower melting temperature than most of the lead-free stuff. So it makes it a little bit easier, especially on these, because you want to have the heat on these as short of an amount of time as possible. It's not good for them, but kind of got to do it. I'll bet I could spot weld these on. Might have to tinker with that. That would be better. For the soldering, I'm using this Weller 100 watt soldering gun. This produces more heat faster, and that's what I'm after. Enough talk. Let's do this. Alright, so now what I want to do is check my wiring, because, well, why wouldn't you? So, put my main negative here, and then I want to see about 4 volt increments. So there's my number 1, 4.15, 2, 8.3, 12.4, 16.6, 20.7, 24.95, and 29.11. So this is wired up correctly. Now I can wire up my BMS and hook up my battery negative, and I think I'm just gonna do the same thing. I think I'm gonna trim this off because I'm sure that's lead-free solder. I'm gonna splay out these wires, and then I'm just gonna pre-tin an area in the middle of the pack on my main negative, and just, I mean, really just do my best to solder it on. Hopefully I don't put too much heat into it, but we'll see. Alright, so I pre-tinned this with it splayed out. So I'm hoping that between the solder in the wiring and the solder on here, I don't need to add any, so I can just hold this and then, you know, take the soldering gun to it and hopefully it'll solder together. So confident. I must admit, that worked better than I expected it to. It wetted right in there, the solder flowed nicely, and it appears to be a pretty solid connection. I mean, this is for a Powerwheel, so I can't imagine they draw a ton of current to begin with. It's a couple of RC motors, basically, with a bunch of gear reduction. So, should be good to go. Now I need to, plug in the balance lead into here, and then figure out where I'm going to put everything, you know, finger movements. And then I have some shrink tubing that I'm going to slide this into. Something occurred to me as I was watching these two wires flop dangerously close to one another while being connected to power. In the future, I'm going to solder this connector together before I connect the positive and negative. The BMS should protect it, but I don't want to find out if it would fail. So, alright, that's done. That was easier than previously, but still not as easy as it should be because I don't know what I'm doing. Alright. And no soldering job would be complete without a little bit of the wire poking through their little cover, because that's just the way it goes. Alright, so now I can, I think I can put the shrink tubing on. Might tape this up a little bit, but I think we're pretty much ready to go. And checking our connector, we do have 29.11 volts, so we have output power here. Hooray. I don't think it's gonna shrink enough. Can I just use duct tape? Are you guys gonna judge me if I just use duct tape? I think I'm gonna call it good enough. It did not work out quite as well as I was hoping, but I mean, for how large of shrink tubing that was, it did a pretty good job. This actually may be an error on my part. This is definitely an art form. Heat shrinking this stuff is, you know, how much it shrinks in one area affects how it shrinks in other areas. But overall, I think it'll work. So we have 0 through 10. Kind of sad they didn't put an 11, but it's pretty straightforward. So you've got input 12 to 50 volts DC here, and then motor 30 amp max. So what this is going to allow us to do is adjust this, turn it up, turn it down, whatever you want to do. So for the Powerwheel, if we want to run at 12 volts and run it about halfway up, it should put out about 12 volts. So now if you wanted to go a little faster, turn it up. And then wide open if you want to set things on fire and run into a tree. So let's get our wiring for this done. The battery, I'm just gonna add a connector with raw ends, and then I think I'm actually gonna crimp these on just because I have them. Why not? So let's get some 12 gauge wire and put on a male XT60 connector and get this thing wired in. And then after that, for the motor side, I'm actually going to take the original connector from this. I'm going to pop this cover off and, you know, solder this to the output side, just so that way we can plug this directly into the car and not have to modify anything on the car itself. Alright, so I think we are ready to try this. I'm kind of scared, I'm not gonna lie. So I'm just gonna go back through, double check everything. Our main negative here is marked on the side with the chamfers, I guess. And our negative here is marked with the chamfers. We have it wired to the negative. This is our positive, obviously. All that looks right. This, positive, positive. This is our positive, negative, negative, into the negative. I'm gonna turn this all the way down and it clicks.
Do you need more power?
There you go. So she did really good on the lower voltage settings, which were closer to stock, but once we turned it up, she didn't like it very much. I think she will when she gets a little bit bigger, but for right now, I think we're gonna have to keep it on the lower settings. Here's a quick clip of that.
Push your foot all the way down. There you go. Hold on, I'll turn you.
So she wasn't a fan of the higher speeds, but I wanted to get a little bit of footage of that, so my sister-in-law hopped in there and we turned it up a little bit to about number 7, and definitely faster. I was jogging to keep up with her riding it through the grass, which was impressive. And then when we turned it up a little bit more, I popped a fuse. So underneath the main cover of the PWM controller, there is a tiny little cylindrical fuse that is 500 volts and 30 amp rated. 6 millimeter by 30. I know that's blurry, but I picked up a pack of like 10 of these on Amazon for $7. Got here in a few days and stuck a new one in there, and it's up and running again. So I think the high inrush current of the Powerwheel, when you have it at a higher voltage setting, the torque that the motors are trying to produce increases the current draw. So it popped this fuse. I think with like a kid riding around on concrete or something like that, where the wheels can spin and kind of slip a little bit, you won't have that problem. But being on grass, we threw some bricks in there to try and get traction and everything, and at the higher voltage, it just popped this fuse. So all the way up until number 7, it seems to be fine, but at, 29 volts, it doesn't like it. Who would have thought? It cruises. Hold on. There. It's almost, just about.
Uh-oh. It's dead.
Hang on. It was probably the BMS on it. Hold on. I don't know, you might have to charge it to get it to work. Is it working? So it went into short circuit protection on the battery. So as you heard in the video, I thought that the BMS went into short circuit protection because that's only like a 40 amp BMS, and I was like, maybe that sudden inrush it was enough to kick it off. Didn't think it would be a fuse inside the PWM controller, because I figured being like $12 or whatever it was, it wouldn't even have a fuse in it. So yeah. So I could have built this battery differently. I could have done this conversion a much simpler way. I've seen like DeWalt 18 volt battery pack hookups that you just wire into where that connector was on the Powerwheel, and you just slide an 18 volt battery on there and you're off to the races at 18 volts. Would have been a lot easier overall, but the way I did it allows me to use it in different projects. It also gives you the flexibility to adjust the voltage, whereas just a standard connector would not. You get 18 volts and that's what it is. With this, you can adjust it so you can make it more age appropriate, as age appropriate as a massive battery can be. Don't let the kids see you adjust the knob. Alright everyone, this ended up being a longer video than I wanted it to be, but I covered a lot of the detail. I wanted to go through the battery building process because that was the primary reason to make this video, but it was kind of cool to see the end result as well. My niece is a little bit more hesitant to ride this type of stuff, but my daughter doesn't seem to be. Check this out. So we have some daredevils in the family, it seems, so maybe I will find some old power wheels in the garbage and go a lot higher than 29 volts. It won't be for very long, but I'm sure it'll be fun while it lasts, because those motors will go up in smoke, but who cares? Got it out of the garbage. Alright everyone, that's going to be it for this video. Thank you all for watching, and I will see you on the next one. And so the editing begins. But what we're gonna do is lay this thing out, and I've already done it. Well, that sounds dumb. So it actually should be a smaller battery, and I went through and set all of that so that I could say this is. So what we're gonna end up with is approximately a 24 volt battery and 24. So now I have all of our... So she wasn't a fan at the higher speeds, but I did want to get some footage of the higher speeds. So underneath the main cover of the PWM charge, or 500 volts. Hello? Alright everyone, thanks for watching. Nope.